Hello class, welcome back to my class. Let's see how we can solve this. 16 can give us 4 raised to power 2. Then we're going to make sure that we expand this, or we break this down into 2 raised to power n times 2 raised to power 1. Know that a raised to power m times a raised to power n is the same thing as a raised to power m plus 1, n plus n. So the same thing we apply here to get this. So minus 4 times 2 raised to power n over, if you do the same thing here, this is the same thing as saying 2 raised to power 4 times 2 raised to power n times 2 raised to power 2 minus 2 times 2 raised to power n times 2 raised to power 2. If you look at this, we make this easier for ourselves. In that way, we know that all these are contained in here and all these are contained in here. So what we have to do is to find the factor between these. So the factor is going to be 4 times 2 raised to power n into bracket. We know this, so we're going to have 4. This is contained here and this is contained here. That means we're going to have 4 times 2. So 4 times 2, let's put this in a big bracket. So 4 times 2, if you expand this, you're going to have this. So this is 4 times 4, 16, times 2n, times 2. So that is what we have. So minus all this is going to give us 1, because we have all this as 1. So divided by, if you look at this, all these are contained in here. So we're going to put that out. That's 2 times 2 raised to power n times 2 raised to power 2. Then what is the factor that we have here? So that means we're going to have, in this way, we're going to have 2 raised to power 2. We're going to have 2 raised to power 3, rather. We're going to have 2 raised to power 3 because of this. 2 raised to power 3, this is contained, so we have 2 raised to power 3 minus 1. So that is what we're going to have. So in that way, if you look at this, it shows that these can cancel out this. These can cancel out this. So, and if we solve this, that means we're going to have 8 minus 1 to give 7 divided by 2 times 8 minus 1 to give 7. So 7 cancels 7. So the answer here is 1 over 2. Hey class, another way of solving this IMO question is this. So we know that 16 is the same thing as 2 raised to power 4. We just need to expand this times 2 raised to power n plus 1 minus 4 is going to give us 2 raised to power 2 times 2 raised to power n. So we're going to do the same thing here, and this is going to be 2 raised to power 4 times 2 raised to power n plus 2 minus 2 times 2 raised to power n plus 2. So what do we do here? So what we do here is to look at this formula that says a raised to power m times a raised to power n is going to give us a raised to power m plus n. So we are going to apply that here, and if we do that, that means we are going to have 2, which is this base, 2 raised to power 4 plus n plus 1. That is what we have here, based on what we have here. So minus, we're going to do the same thing here, 2 raised to power 2 plus n is that base. If we have done that, so divided by, we're going to do the same thing here, and that is going to give us 2 raised to power 4 because of this law. So we're going to have 2 raised to power 4 plus n plus 2 minus 2 raised to power 1 plus n plus 2. I'm pretty sure that this is clear to us here, because we can use this law that says that. So what are we going to have here? So if we do this, this is what we're going to have. We're going to have 2 raised to power 4 plus 1 will give us 5 plus n. 5 plus n minus, this is going to give us 2 raised to power 2 plus n divided by, if you apply the same thing here, we're going to have 2 raised to power 4 plus 2, 6 plus n. 4 plus 2, 6 plus n minus 2 into 1 plus 2 to give 3 plus n. So now, if we look at this, and following the same law of indices that says a raised to power m plus n to give a raised to power m times a raised to power n, this can be rewritten as 2 raised to power 5 times 2 raised to power n, right? Minus the same thing here to give 2 raised to power 2 times 2 raised to power n. So we're going to apply the same thing here. I'm pretty sure you understand what I'm trying to do here. This is the law of indices that I'm using to expand this. So we do the same thing here. So this is going to be 2 raised to power 6 times 2 raised to power n minus 2 raised to power 3 times 2 raised to power n. From here, we can go back to the factorization method. What are we factorizing? We know that 2 raised to power n is common, so we can take that out. And if we take that out, again, 2 raised to power 2 is common. we can say that 2 raised to the power 2 times 2 raised to the power n, which is common. So that will give us 2 raised to the power 3, because if we look at this and we follow the law of this is the same thing, because we want to get this, or the same thing here. If you do this, multiply this and this together, you're going to have 2 raised to the power 5. 2 raised to the power 2 times 2 raised to the power 3 we give 2 raised to the power 2 plus 3 to give 2 raised to the power 5. So and this is common here, so that one is fine. So that means we're going to have this. Then minus 2 raised to the power 2 times 2 raised to the power n. We have this common, we have this common. So we have this one minus 1. Then divided by the same thing here. This is common in both of them. We have 2 raised to the power 3 times 2 raised to the power n into bracket. So what do we have? So this one is going to give us 2 raised to the power 3 also. 2 raised to the power 3, and this is common. 2 raised to the power 3, this is common, minus 1. You can see clearly that it's easier for us to go in many ways. So in that way, these can cancel out this. And since this is the same thing, this can also cancel out this. What do we have left? We have 2 raised to the power 2 divided by 2 raised to the power 3. Because they have the same base, it can be written as 2 raised to the power 2 minus 3. Following this law, we have m minus 1, a raised to the power m minus n is the same thing as saying a raised to the power m divided by a raised to the power n. So if we follow this law, this law that says a raised to the power m divided by a raised to the power n, which is this raised to the power 2 divided by this raised to the power 3, because they have the same basis, so you take one of the bases, which is 2 into 2 raised to the power 2 minus 3. And if you do that, this is going to give us 2 raised to the power minus 1. And 2 raised to the power minus 1 is 1 over 2. And that is the answer. The reason 2 raised to the power minus 1 is that we have in the law of indices that a raised to the power minus 1 is going to give 1 over a. And that is the answer. Our answer to that question is 1 over 2. Thank you very much. I'll see you in the next one. Bye.